All right, so a quick comment on the cam. Those were optional. I didn't put that in when I added the videos, but pretty much trying to equate or relate the process of setting up, generating code for the machine tools, and the way that the different programs manage the coordinate systems, the way we generate flatness and parallelism and perpendicularity and going through that. And it kind of goes back to the very beginning where we did that kind of that quick stack up on the machine simulation, where it had the table and then if there's a subplate and how parallelism affects the vice and the vice and the stack ups, and then the parallels actually going into the vise, and then finally we would have put apart. Each one of those elements is something that can affect our tolerances. So as we think about dimensions and we think about how to accumulate, I think this is still an important part. It's not meant to be a CAM, just CAM class, but to say that you have some exposure to what was how it generates, and on the manufacturing side how it gets taken up. So so just keep in mind there's optional. There's nothing as far as an assignment attached to the CAMs. Our process is to make those passes, and so if you've made a dimension pass on the CAM follower, then we're going to follow the same kind of steps of make a just the overall dimension, decide what our critical dimensions are that will become our basic dimensions that get applied and controlled by the geometric feature control frames. All right, so the other side of this was the that we had all three strategies. And just to review, the bottom up is probably the most common, where you create each of the parts get assembled, and you have a finished assembly. That has a lot of stability in it, but it's not fast, or not as fast. The multi-body parts have the advantage of relating everything into one part with the multiple bodies, which in the case of an assembly, a purchase part is what I typically will tie it into. Or in the case of the base, where it was a casting and we're trying to break it up into its components to make it separate pieces and make it manufacturable, then the multi-body kind of applies. The top-down assembly, if you got those files. This was the follower itself was pretty straightforward, but it allows you to tie things to other things, right? So those components have those external relations, have an associativity between the items that helps you to visualize, and then makes the build that much quicker. All right, so I'm still trying to figure out why the dim expert didn't that we applied to the model didn't all come over. I mean, we have at least some basics, and when we look at the annotations, so let's see if I show the feature dimensions. Let's see, dim expert associate annotations. So they're there. And not quite sure why it's not coming across. And we went through the process of generating these, and even when we did an inserting of a fresh view, they didn't all come across. So that's kind of I'm not sure if that's something going on in the software. My expectation was that we generate this, we modify it, we now have something tied to the document, and even though we're focused on ASME Y14.5 2009, 2018 is going to allow this to be a working document. So if you've made this our dimensions and we clean it up, we do a little bit more management of the views, I could send this to a vendor and say, this is the document. This is our working contract. The dimensions, standard tolerances, I could put notes back over into the file properties if I thought I needed them, and we could go from there. But pretty much for all accounts is going to the 2018 standard. We can utilize this as a document. So the one thing I did notice when I was tinkering a little earlier was if we go back into the model items and we're importing to the entire model, and I went back and I just selected everything. So datums, datum targets, the geometric tolerances, weld symbols that don't exist, everything that's in the other group, the notes, the annotations. And I don't really see those come across but it got a few more items. So if you applied it, then we could at least get one or two items out of the group. All right. So one of the things I want to jump back in real quick. I believe we covered this, but I want to just give it another mention. Is under the options. So the little gear in the upper right, go into the document properties, and under the document properties you have Dim Expert. And so you can pick the dimensioning standard, block tolerances, general tolerances, basic plus minus tolerances, a tolerance class. For the size dimensions, we are in inch, so plus or minus 5 thousandths. I believe the standard is, the default would be about 20 thousandths, 0.020 on all of these. So we tighten those up a little bit. And then the location dimensions, chain dimensions, and then getting into the tolerances. All right, and then so Chamfer Controls, let's see, that looks okay. Display options, those all look okay. So these being the defaults, it's going to refer back to. And since a lot of these are showing up in 2 decimal places, we have a few at 3. If we go back into the document units, right now our inches are in 2 decimal places, so at some point I was tinkering around. So let's go back to millimeters. Either this was metric and we went to inches, or vice versa. So millimeters would typically be 2 decimal places. All right, so it doesn't necessarily update, but we're able to control these as we go through by picking the call-out values and the type of tolerance, and then what that tolerance is or becomes. So each of the items has then the counterbore diameter, counterbore depth. Each of those can be controlled from within that callout. All right. So if I decide I need more precision on the 0.43, we can go back to that hole diameter, and I can go to 3 decimal places. And from our standard, we also need to make sure that the tolerance has the same number of decimal places as we made the primary. So looks like those jumped up. So let's go to the counterbore. Okay, so that one updated, and lastly that one updated. So if we kind of tinker around with it, I believe that if it was in the 3 decimal places when we applied it, it would carry across rather than having to go back through and update. All right, so like the 610, let's just check one more time. Oh, not a min. There we go. And then a 3 decimal places. And if we do same as nominal from the document, then it will go find that value for us and carry it across. On the other side, maybe this doesn't even really need to be a plus or minus dimension. So a lot of times what I'll do if I'm just reading this for the process of manufacturing the part, I'll switch it over to a general tolerance, which will take that symmetric off completely and treat it as the our manufacturing process, plus or minus 5, plus or minus 10 thousandths for those geometries. Right, so we have some options even within this document to control, but because we don't have the title block, my assumption or my belief is that each one of these dimensions has that symmetric, has the limit, has whatever associated to it, because it is not being defaulted in the title block to have that tolerance zone associated with it. All right, so let's go ahead and jump out of that. All right, and so for the pass, and I think I'm going to run out of room pretty quick. So 1 to 5 is pretty small for an A size. Let's see, did that one, that must be the parent view. All right, so based on the hierarchy, use the sheet scale, use the custom scale. So let's see what happened to that one that it didn't update. All right, so 1 to 5 is a little small. I don't know that I needed that to go that small. So clicking in the right-clicking in the work area gets me into the properties. This is where we have all the sheet, but also that we can come back and pick up the scale. So if I was to go maybe 1 to 3, that gives me a little bit more room. And I'm less picky about scale and more picky about readability. So puts it on the size, makes it visible. I'm going to go with that first. All right, and then also of note is that the kind of teal, green, whatever that is coming over as the DEM expert color. So if we wanted to change those or update them, then we would have to change the layer. And I don't really want to take it into the detailing that far. We have enough to contend with without worrying about that as geometry. So we have the 0.59 plus or minus 10 thousandths. That is probably a good tolerance for the thickness, but we're going to control it within that tolerance zone by applying the flatness and parallelism. So having the dimensions, picking up a datum feature, and either applying it to the extension line or to the object. And then because we did this as a multi-sheet drawing, the other choice you have to make is, are we going to start over ABC with each sheet, or are we going to go continuous? All right, the software is going to want you to go continuous. It'll ABC, and then if we go back to A on sheet 2, it's going to tell us, well, that one's already in use for this document. All right, so on that end, I think it's a little bit easier, but it's also going to be a little bit more to control and maintain. So we'll see how it goes. So you would pick your flatness, you would pick your parallelism, and I do want to leave you some functions. You get to pick what you want to apply, where you want to apply it, and think about the process. So the hint as we're going through this is, since this is our datum simulator, this is what we're going to put on the surface plate, being this face, and when this rotates over, the bottom of the top view, that is a candidate for probably a better candidate for the A datum, after I go ahead and just slap it onto the top, thinking that that's a good place for it. And then the parallelism would actually be the back side of this part, because it will have the parallelism, but that is where the next vertical piece comes in and starts to build up and has that next contact. All right, so if I can grab that point, and drag it out and away, I can always change my datums as I think through the process. Right, so until we get to a point where this is reviewed, that we've all agreed that that is an appropriate datum where we want to place it, the visual on it, we're able to make those adjustments. As far as our B datums and B and C datum, those are pretty much arbitrary. We're not sure of what the connecting piece is. That's one of the things I have on my to-do list, is to think about what this plate is mounting to and the frame or the structure that's going to support it, and kind of build some of those additional items out. Right, so if we just pick kind of on the left and work that way, we'll go with the baseline dimensioning. I am not a big fan of chain dimensioning. I don't know too many people who are. The accumulation of tolerances, if this is plus or minus 5 and I go from here to here and that's plus or minus 5, when I get to the last one, I have 4 places that it could grow by 5 thousandths. The last hold position could be out 20, which totally changes the positional of the of what that last hole location can do. All right, so we'll avoid the chain dimensioning, and I'm going to go through and pick up our geometry. And one thing of note is that I am picking the center points, or the center marks. So as you're picking those center marks, make sure that you are getting the horizontal or the vertical, depending on what you're applying. Otherwise, go to the one of the hole locations or one of the hole geometries and pick it over the center mark. All right. So one of the downsides of baseline is that it accumulates a lot of dimensions fairly quick, and then after I get them placed, I'll see if they center up okay, and we have a little bit more room there. All right, and then if we need to, right-clicking and going to the display options, we can center, or if we were to pick all of kind of a window pick, I can go right-click and center the dimensions, and it will center them within the extension lines as a group. All right, those are minor details, but it makes it look nice. It makes it a little bit more readable. All right, so our vertical, before we go through and we start thinking about critical dimensions, let's see, I need to get that one in there. All right, so these are going to get kind of cluttered again. Oh yeah, need to have the pins. All right, so as these stack-ups get more complicated, I'm going to again do the window pick. I didn't really need the horizontal of that one. And we'll go back to the display options and tell it to center the dimensions. All right, so the fun part then is kind of positioning these, and I will kind of stagger them. Let's see, is it jumping back to center? All right, so in that case, because I'm running out of room, okay, after I centered it, now I have to tell it not to center it. So that we can make enough room to get in there for all of those without losing too much of the geometry. All right, so I think for space, I'm going to bring those two down. All right. And then as far as the extension lines, we have 2 items, then 5 items. All right, so if I were to drag the extension lines through, that would be the notation that it is for both. But since I didn't, we're going to go to a 2 times notation, which is going to stretch it out a little bit. And I deleted the bracket, so it warned me. All right, so I have a 2 times. And they're going to keep moving around on me in a little bit. And a 2 times. And then this one would go to a 3 times. All right, so we can pick up those values and make it a little less busy as we go. All right, so zooming over a little bit, and keep in mind that the top view in this one became the parent view. So when I want to position horizontally, I have to drag that top view to get it in a little better location. All right. So we have our dimensions. Well, everything except for the overall. So since I'm kind of running out of room anyway, I'll bring it over to the side. We said our overall could be 2 decimal places, and we'll stay in that sequence. All right, and then we have the call out for the counterbores. So as I identify those items, I don't think the counterbores are really the critical. The pins are the critical items. So those are going to be, as we start thinking about our tolerancing, those are going to become the dimensions that pick up the basic. All right, so the 1.575, that gets a basic, the 3.4543, and that gets the basic dimensions. All right, so it's stretched out on me a little bit more, and we'll kind of bring that in. All right, so your task is to think about the positional tolerances for each of the hole locations. Now that we've established those positions, and let me go ahead and save the document. That do they need to be 2 decimal places, or in the case of the pins, that if we actually bring this over to, let's see, that picked up. All right, so since this picks up from the dim expert, the values, the style, the tolerances aren't accessible. So that's going to be one of the considerations of, do we use the dim expert or do we apply it ourselves? So I'm not real concerned about the 0.79 plus or minus 10 thousandths, because if we make it even plus or minus 10, we've got a 3/4 inch bolt. They're so oversized, even a 19 millimeter bolt is going to kind of float in on that size. We've been overly generous with the tolerance, so I'm maybe not as concerned about the positional. The same can pretty much be said for the counterbores. There's enough clearance, there's enough room that maybe they're not the ones that I'm really trying to tie into. So that being the case, since I don't have access to its tolerances, then I'm pretty much going to get rid of the dim expert, and we'll go back and pick up a hole call out, and it gives me the 0.313 through. Since it didn't give me or repeat the 2 times, and it's warning me, do you want to, it could potentially break the link, and at some point I click don't show again because I get tired of clicking that. All right, so we have the 2 times. Let's see, I guess we did the 0.313. And so with that selected, this is where you would go into the tolerance, and we pick up the positional. We would give it, let's go with a, well, let's stay with the 5 thousandths initially. We need to think about what it can grow, because this is that pin and bore condition to where on this side it is going to, our press tolerance is going to determine whether it's a transitional or interference fit. So let's go to Datum A as the primary, Datum B, and we'll add maximum material condition. I was thinking to all of them. All right, so 5 thousandths maximum material condition at maximum material condition to A, B, and C. All right, so in this case, and this is one that I'm still kind of working on, is the fit with tolerance, and the getting familiar with the terminology. And so all I'm going to say on that is, as I develop it and I build it into my vocabulary, watch the videos over the summer, the videos that are upcoming, because I'm still processing the shaft basis and the hole basis for the fits. So as we go through, then the H value is the hole tolerance, and then the G value, or the uppercase value is the hole value, and then the G value, lowercase, is the shaft tolerance. Right, so we can go through and we can relate those, and the more I look at those charts and the variation as you get to larger shafts, larger bores, it opens up those tolerances by percentage, so that you have a greater flexibility in the group. All right, so for this particular one, it is going to be a press fit. So I would need to pick up the tolerance, and we're in 3 decimal places. I'm going to say, does it still let me? All right, so this is where we get out the chart and we look down through and we see the CDs and E's. So an H6 tolerance with a plus nothing and minus 1. I'm going to set it out to 4 decimal places so that it picks up. All right, so it gives me a tolerance of plus 4/10. So apparently I picked, I got the hole fit. So let's see if we can pull that back out. All right, didn't like that, but let's go over to the and see if it'll give me the G value. All right, so in this case, and again, this is where I'm struggling a little bit with the terminology, is that if we've set this to be a shaft basis, then we're 2/10 to 6/10 undersize. So the 3 or 4 decimal places says that I could ream this. I could ream this with a 1/2 thousandths under, so a 3/12, and that's going to give me that interference light press. So a light press would be that 2/10 to about 6/10 up to about a 1/1000th of an inch. And then getting into the heavier press fits, you go up to about 2 or 3 thousandths, and then you're going to have to put some serious load on it. You're probably going to end up at a 5/16 steel pin. At some point, you're going to end up deforming the material, deforming the pin. And then the other side of it is, at what point does it become a heat shrink, where we have to heat up the base, throw the pin in the freezer, and when they slip together and everything contracts, they are one piece pretty much from that point on. All right, so this is something I want to build into and I want to make you aware of. I don't know And I said what I'm mostly used to doing is just giving it the four decimal places and saying plus nothing minus 1,000. If we end up in that area, that pin is going to press. What we haven't decided yet, is this a steel? Is this a stainless steel? Or so like a plain carbon, 1018, 1020. Is it a stainless steel? Is it aluminum plate? All right, each of those materials is also going to affect some of this tolerance, some of these decisions that we're making as far as this tolerance zone. All right, so at this point, when we go back in and actually apply the tolerance zone, so let's see, that was the datum. Let's see if we get the geometric. We got the fit. And did it kick that out, or did I just not apply it? Okay, we'll come back to the maximum material. All right, so there it's showing up with it. And I have a, a full dimensioned piece. All right, so, again, the basic dimensions, well, lost one. And that's going to be one of the reasons why we make multiple passes, is that I can go through this thing probably 3 or 4 times, and every time something else will jump out at me. Problem with the detailing, the problem with thinking about these tolerances, you get very myopic focused on what you're doing and the little things that escape you. And so going to the next one, getting it to a point, going to the next one is going to allow you some time to digest and to work through, so that when you come back to it, you can pick up those other items, those things that might have escaped you. I still want to put that one somewhere, but okay, probably going to have to do. All right, and then the outsides are not controlled radiuses. The diameter we talked about. And what I don't see then is a, oh yeah, we got the counter bore. All right, so we're all covered. All right, so on the other side of this this drilled and reamed call out is selecting a pin. So if we go to a standard dowel pin or pick up a precision, probably a stainless steel 18.8, what else would it be, 3, anyway, one of the 3 series pins, that would also give us the shaft size and how much actual interference we could expect from the part. All right, so since we went all that far, let's go ahead and set the flatness. And we'll try and keep it fairly close. And got to remember to make sure that it gets applied. And then picking up the parallelism. All right, and so since if I brought that down, it would basically stack or interfere. Just going to let it point at this point, or let it point. All right. So still a little messy, needs another cleanup, but that gets you the majority of the dimensions. All right. Okay, so I need to leave you some to work on yourselves. So I will make the recommendations that on this piece, give you a nice, nicey juicy one to get into, is that this lower, and I still haven't figured out what's going on with the cosmetic threads here. So not sure if we can hide those. All right, so you are probably going to want to do that then. I'm not sure why those are showing up in the first place, since they're on the back side, but they are making the drawing a little confusing. So what I hope is that it's not hiding them everywhere, it's just for that view. All right. So for this, since the base, we've talked a little bit about rotation. I'll run through the rotation one more time. So if we wanted this to go more elongated, across the face, maybe have a little bit more room to work with, and this is where the B-size sheets or the larger sheets come in, have the better option. So I don't think, and then we're going to have to come back and hide the cosmetic thread in that one. All right, I think it's just going to be one of those things. All right, so whichever orientation you prefer. And then if that's the case, we need to add in an additional view. So going over to the View Layout tab up to the projected view, that will place the one that we got rid of, and sure enough. All right, so there's got to be a better way to do that, and eventually I will find it. So let's go ahead and delete that view. All right, so when we're thinking about this, the primary datum, even though our datum simulator would be the one of the larger faces, the primary datum still is where this connects to its mating part, the mirror piece. So I would think that this edge would be A. We could pick an arbitrary for B, or through the center of the bore as a B, and then or maybe the let's see, which one would that go to? Yeah, I guess one of the faces, so that we could have a B, and then in the counter bore, or the little spot face that the housing sits into, we could pick up a parallelism with that. All right, and then our basic dimensions really come back to the center of this bore in relation to A. And as we go through the process, then the positional tolerances are the threaded holes, or these are the clearance holes. Yeah, these are the clearance holes on the plate side. All right, so basically what we just did on the base, you're going to do going through adding dimensions. And expect that this is going to get a little busy. So the recommendation would be, instead of the baseline dimensioning, is that you pick up the ordinate dimensions. And since we picked that as kind of our primary, then I can go through and pick up those dimensions. So if we do a quick check, okay, that just duplicated the dimensions, so they share the same. And undo one more time. And then again, if you wanted to, most of the time I'll just pick the ordinate dimension over vertical baseline. By the time I figure out which is which, I can already pick the ordinate and go from there. So, all right, just to give you a start. So as you go through, you would pick up the basic dimensions. Start to pick out your tolerances. You're going to have some flatness, probably some perpendicularity, and then the positional tolerances. And again, for the pin, let's take a look at this one, because this will be on the upper side. We want this side to be float if the other side is press. So if I go into the hull callout again, I'll pick that. It gives me the depth. I'm going to give it the designation for the 2 times. And that's getting very close to getting turned off. Alright, so when we pick that up and then go into the tolerance zones, then a fit with tolerance. And let's see if we can go. Alright, so an H7 plus or minus 1. I want to see what that looks like with a 4 decimal place on it. Alright. So other than finding a spot to put all of that in, that still gives us a pretty decent range for the clearance. All right, so this one being a +6 minus nothing means that at the very least there will be a 0.2 of a thousandth clearance on the pin. So even that's going to be a pretty tight fit. So chances of being right at 0, right at the lower end or right at the upper end, I'm sure on occasion it's going to happen. So again, the H values, the fit tolerances are optional, but I think that as much as I see those coming up, especially in taps, I've always kind of had a general sense of what those G and H values are doing, but not really, a good, apparently a good understanding of what's going on. All right, so I'll leave the rest to your devices. All right, so for the angle plate, let's, I think we're probably okay on size. And we'll pick up the dimensions. All right, so 3.15. Set an angle. All right, one of the things about the angles too is that I want to place it, and then it doesn't have to stay there after I've placed it. I can always pull it out, but to make sure that I get that included angle, get that included value, I need to be between the two lines. All right, so when we pick our datums, they're going to be pretty consistent. This one's going down on the plate, and this one's going up to the vertical. And then let's see if we pick up. All right, so let's go ahead and add a datum, and it's going through the list. All right, so this is that. Since we applied the A datum over on the others, and I'm kind of out of sequence too, because if you did sheet 2, you would be picking up probably, well, what did we have? A, B, and C was the call out. Oh, I guess that was one that you didn't go back and pick up. Since I called them, I better define them. All right, so here's where it gets interesting, is that since I jumped, then I'm out of sequence on those values. All right, so if this is B, and was kind of expecting a warning maybe on the next one. All right, find a spot. All right, so we'd probably have A, B, C, D, E, F on this one. Let's see what happens if we go back and we pick up an A datum. So the only real thing is that we have to control those values. All right, so flatness and parallelism, I'm not overly concerned about the vertical. It's not really contacting anything. My two contacting faces are pretty much set. Oh, okay, find a spot. There we go. All right, and then to apply the angularity, and let's just give it 5,000. So on this end, it doesn't really need angularity. It's more of just an excuse to apply it than anything. So giving it a 5,000th angle zone will more than suffice for the contact. All right, and then the 45 degrees default plus or minus a degree, we should be able to pick that out. All right, then the position on the two hole locations, those will go through and be under standard tolerances. All right, so I'll let you take those on. I think that one's probably pretty straightforward. Again, the hole call out, when we grab one of the hole wizard items, it's going to pick up that value. All right, so this is directly out of the hole wizard. It still didn't get a count though. So I'm not sure why it's not going for the instance count. All right, I'm done with that one. All right, so 2 times 260 through 496, and I think these were for an M6 anyway, so that has a fair amount of clearance. All right, so you pick your A datum. We're looking at this based on the way that this folds over. Probably the bottom of the part, which would be the top of the view. Right, so kind of this back surface would be the one that I was going to pick up anything for flatness. It would be in that area, or we could experiment with applying some datum targets, but it's pretty small, so I don't know that the datum targets really apply here. Keeping it in the range right around that point. All right, let's get to the fun one. So on this one, I gave you a section view. And looks like we didn't get to an isometric view, and it's going to be a little busy anyway, so we'll come back and set a custom scale so that we can reduce that a little, tuck it up into the corner. All right, so kind of the same as the conversation we had on the cam for the shaft is picking those datums, picking up the run out, and really, since this part's being turned on a lathe, as much of the geometry as we can generate is going to pick up our on the same center is going to pick up that run out. The callouts, I don't know that I would stay with the M6x1. Usually would delete those out, go back into the annotation and the whole callout, and try to pick up the actual. So all those could be positional, but we need to pick up at least one of the items to be our primary datum. All right, so this is going to slip through the vertical, so it's slipping through the bore, and it's going to contact on that face, so those would be potential A and B datums. Picking up the outside diameter. So looking at this from the manufacturing process, one of the things that annoys me as a machinist is when the very last piece of geometry that I would cut is the A datum. All right, so I'd like to have something that is generated early on or has that potential to be controlled on the outset. So in this case, if we go to the smart dimension and pick up the 2.913, even though that is maybe an open tolerance, it gives me geometry that if I'm starting off with the 3-inch piece of stock and I start machining this down, I can establish all of this outside geometry, and when I cut it off or part it off and flip it around, I have something to index to actually measure to. All right, so in my thinking, that would be my A datum. Oh, I like how that one applied since it was selected. All right, and then the run out. And this is not the rotating. So usually I would think of the the rotating part, the shaft having the total indicator run out. So I will give you the option of putting the bearing faces as positional tolerances or as run out tolerances. One of the reasons that I made this part round though was for ease of manufacture, that we would be able to fit it into the vertical component fairly easy. All right. So again, with the bearing Let's see if I have it handy. All right, so I'm going to refresh where I have all of that. Oh, I left it in downloads. Okay, I don't usually leave it in downloads. All right, so this is where you can come back over to the documents. Let's see, we have the ball bearing. See if that's the small one for the, yeah, so the ID, that's the small one for the follower. Let's see. Okay, not opening. All right, so the 40 millimeter OD and the 17 millimeter ID. So this is where we would come back to that tolerance and looking at the ID tolerance of minus 0.007 millimeters. So keep in mind that that's, here we go doing math again. That's very small. All right, so let's see if I can remember that off the top of my head. So the way I kind of work these is 0.1 millimeters would be about 4,000th. 0.01 millimeters would be about 4/10. And so we're just under 0.1 millimeters, so about 3/10 of a thousandth to 0. That seems pretty tight. We'd have to do the conversion on that one, but at least it gives me a ballpark on the shaft. And then the OD tolerance minus 0.011. So it would have a tolerance in the range of, like I said, 4,000ths to about 4/10 of a thousandth. All right, so those are going to drive the numbers on picking up that bore. So since we haven't done a limit dimension, then we'll update the precision to a limit and go to 4 decimal places. All right, and then the minus, or would this be a plus? All right, so if we go minus 4/10, then if I was to go plus 5/10 of a thousandth, all right, or half a thousandth, that would give me a range a little bit on the higher side. Or we could look back at the fit tolerances on the dimension. Right? Since these are pretty much the same, choice is to apply the dimension again or give it the 2 times. And then really the virtual condition of the datum is that central axis. So since we haven't added a center line, let's go ahead and pick up some geometry, and then I can pull these out. All right. So having done that, the bores are the ones that, maybe this is A, this becomes B, and then even one of the bearing faces could be a C, so that we could relate the other one as a position to all 3. All right, so I'm still kind of juggling that one. Let me know what you decide. All right, so the not critical dimension here then would be the 709. It's just acting as the clearance, right, for the shaft. And so I want it to be fairly close, but it has enough clearance. I don't want to drill it any larger than I have to. The other consideration that we didn't quite, or at least I didn't show up, is a lot of times the bearing face, the inner race, will have a little bit of a raised section. We'll be a little bit proud of the dimension, and that would be something that would rub on this inside face. So there may even need to be an additional spot face in here that remains to be seen. But that's another one of those tight tolerance, open tolerance, open tolerance, open tolerance, tight tolerance. Right? We're going through and we're making those determinations of based on the functionality of the parts as we go. All right, so positional on the M6s. We have a standard tolerance on the OD. Would need, I think I intended for this to sit on that through bore in the vertical. So it's going to be your choice of, do you control this outside diameter fitting into the spot face on the vertical, or do you control this secondary, or this second step, and have it be the slip fit, all right, giving it a positional location, but also taking some of the load and transferring it from the housing into the vertical. All right, we'll come back to this one. All right, so I was, of course, on the drive home last week, was running back through all of this and picking the A datum. Again, the issue here is this is a piece of geometry that is probably second or third in line of being generated. The other examples that I saw that made sense, but still were a little bit confusing, since we haven't determined that the manufacturing process will require a number 2 center drill, and since the tap portion doesn't have it, that you could make the angle of the center drill an A datum, and then the angle, if we had one on this end, a B datum, and all of our runouts, A to B, would be between those two items. Right? We made the perpendicular, since that, whatever we said, 2 kilogram mass rotating out there off center is all hanging off of that shaft. We wanted those to be fairly tight geometries. Have the positional of the keyway, be able to kind of open up so that it doesn't have to be as tight to fit through the cam, but still take care of all the tolerances. So still thinking about that one. I'm fairly satisfied with the shaft being the A datum, because that's what has to line up and go through the 2 bearings centered in the housing. All right. So our domino effect now comes down to the cam, which is all of that rotating mass. And we kind of left this one, kind of had visions at some point, just to make it look cool, of putting a nice, wavy surface so it kind of oscillates as it's going around. You're doing something that's a little bit more functional with the surface of profile, but this gives us a chance to apply one, so we'll take it. The through bore did not end up with a center mark, so let's go ahead and apply it. And when we apply this dimension, I'm thinking, all right, so since this isn't interrupted, would still think of more of the along the lines that this would be a diametral dimension. So jumping over to the Leaders tab, telling it to switch from radius to diametral, we'll put it into in that location. This is going to have that other basis of the shaft. We would have to consider the fits. Is this going to be a plus nothing minus 1, or a plus nothing minus half a thousandth? And then we come over here, and this is a plus 1 minus nothing, Right, so we need to do something with those tolerances. So if you want to continue with the H and G values, it doesn't look like we can do basic and limit. So I'm going to need to pick that up. Actually, I'm not sure how to pick that up some other way. We're going to have to look into that one. So if I make that a basic dimension, we have the outside. So maybe that one does go over to limit to establish the first and act as the datum. So let's give it, since we're not going the fit method, let's go ahead and add it, and then we'll pick up the profile as a basic dimension. All right, we can center the keyway as a position. And since we're gonna keep updating these, let's go with the A datum. We have the basic dimension, and then the geometric tolerance we'll pick up is the surface of profile. And let's give it 5 thousandths in relation to A. We'll place it. All right. So again, not the maybe the best use of the surface of profile. We could certainly has a lot more functionality than the outside geometry. For your B datum, then, again, that primary, the datum simulator would be picking a face, having flatness and parallelism, and then we would need to see if positionally, well, since that's our datum reference, everything comes off of it. The surface of profile kind of reverses that action. So, it applied it. Oh, it applied it to the basic dimension. All right. So I don't need that one. I didn't catch that. All right. So we'll think through the rest of the process on that one, so we can kind of wrap this pass up. All right. So when we looked at this one, really the only critical was the width and position for the through bores, that they line up and stay in sequence. So this might be a good place to pick up the section view. I don't know if I need, if I do a section view, I don't really need the right view, but I would like to show both of the bores at the same time. So back in the view layout, I'll go to the section view, pick a vertical, go ahead and hit OK, and that can be section B. All right, so if we go back to the baseline dimensions, we'll do the overalls. Can apply the radius, and in this case, we'll just say it's typical. The other thing is it doesn't need to be 3 decimal places by any means. All right, it's not a controlled radius, so we want to leave that as open as possible. And then we need a center line. I'll go ahead and accept that and pull it through. All right, and then really from the position, as long as those holes are in line, I don't really need any kind of flatness and parallelism. I do need position on that width, or a position on the holes, and a max min on the width. So this is one I didn't think that far ahead. So let's go back in the annotation. We'll pick up a hole call out, 250 through. You know, the designation would, if it was just through the first, it would be near wall. We could put a note, add to the note through both or through all, or just the designation of 2 times. All right, because it's a disjointed or not continuous feature, then we'll want to take that at least that much into consideration. So all right, I'm gonna have to kind of think about how I want to do the positional. If that becomes the datum, then we could make sure that that was positional in the same size. This is going to be a press fit, though. If we just used a standard dowel pin, we looked at the other shaft here, and so that one was for the 17 millimeter. Let's go back to, all right, so minus 3/10 to 0, and so if we used even a standard dowel pin, we probably need to be a little bit even undersized of the 250, otherwise we're going to be using the green Loctite to make sure it stays in. Alright, so let's go back to the bilateral. Oh, I'm sorry, the limit dimension. Now we could do it with a bilateral, but 4 decimal places. I think the limit visually has more influence. Let's see, so if they're minus 3/10 of a thousandth, and we need to line that up through the bore, if the pin happens to press through the bearing, it would stay pretty close. So I'm going to go with the 5/10 of a thousandth undersize, and then we'll need to do some more stack up on that one. All right, and then this one can grow but not shrink. I think the width 196, so we made it 197. That's pretty close. So this one I'd want to look at giving it the bilateral dimension of a high side and a low side. So if we said it could grow 3 thousandths, that would put it at a max of 200 in a minute, 197. So 1 thousandth to 3 thousandths of clearance, or so a total of 4 thousandths of clearance if we include the width of the bearing. All right, and the last one, the shaft. So the spherical diameter, nothing really clear here, probably because this is moving up and down inside of that bushing. The main call out here would be to establish the form tolerance of the cylindricity. So circularity, cylindricity, and if we, did I jump over it? Yeah, probably. Yeah, let's give it 2 thousandths. Yeah, fight it, so 002. All right, and then you can put the other basic dimensions on. That's probably pretty good for the call out on the M5 by 0.8 for the machine threads. And if we go in with the relief, just give it some overall lengths, I think that would call it good. All right, so that'll be our pass. Make sure to save it. The other thing of note is we'll have next week for questions, email as you run into problems and issues. But when you go to upload this to Canvas, you're going to want to make sure to grab all of these parts, right? So if you did the dim expert and you brought it over from the parts, I'm not going to be able to see those unless they have the group. So if the cam follower is in that folder, you can right click, do a send to, compress zip folder, and it will gather everything up. I would say put your initials on the end of it, and then as a compressed, well, everything but the drawing. Since I didn't include the drawing, I can always grab the drawing and drag and drop, and it will copy it into the mix. All right, so pretty functional, but make sure that you give me all of your files as you go through, otherwise things get lost in the mix.